Well, hi, good morning. Thank you for joining me in my shop here for another day with this radio. I'm still in the mode of just checking out its operation and refamiliarizing myself with this radio, which was on my bench some months ago, quite a few months ago, and has come back, but my memory has not come back, so a few things I need to check just to be sure of. One of them I should do is take a look at the tuning of the IF on the radio just to be sure it's correct. And another thing of some interest is what's this capacitor still doing in here? Curious about why I didn't change that one out. Looks like I changed out every other questionable capacitor. Looks like this one I left in also, or did I put that in? I think I left that in. Probably on the yeah, I won't guess. I won't guess at what I did. And there was one more factor which has flown the coop at the moment. I can't remember what it was. That was an issue. So I'm gonna. Oh yeah, I remember what it was. So in getting ready for the video here, I thought I'd go a distance and get the sweep generator set to sweep through the IF range and whatnot. And I began thinking about where am I going to connect the signal generator, and a good place would be on the grid of the mixer tube. So which tube's that? So I started looking at the tubes in the radio, going, well, let's see, this is an RF tube, this is the IF tube, it's between the cans. Whoa, wait a minute, where's the mixer tube? What's happening here? Why are there two tubes out here? Usually you would find one tube this far into the radio. Why is there two? And where's the mixer tube? Well, this radio is not as good as I thought it was. Let's take a look at the schematic. Well, first of all, why two tubes? Well, it has an oscillator tube for the beat frequency oscillator in the radio. That's where the extra tube is coming from. And where's the mixer tube? Well, of course, it's right there. What's missing is the RF tube. There is no RF tube. So this is not a terribly good radio. It does have a tuned antenna system for every band. It's tuned, so that can be an improvement over some radios, but this isn't much better than the little 5-tube radio I had in here previously. Not a Hallicrafters, it's a General Electric little radio in a boat. Well, this is the tube I need to hook up to. Getting onto the grid here is a simple matter. I was looking at this yesterday and it just didn't click with me that where's the RF tube. So I just get on the terminal right on top of the radio where the tuning capacitor is. Input the sweep signal, have it go through, and then out here I want to pick it up. I'm going to try to pick it up with a coil. A good place to plant the coil would be physically right in this area, right next to this transformer. I'm not sure if I can pick it up with a coil cleanly. We'll give it a go. Well, you know what, I could actually hook it up as I did yesterday. When I hook it up direct to the same spot I had yesterday, top of the volume control right here, input side of the volume control. I'll hook the SDR antenna there. We'll see what's coming out of the IF. I'll put a sweep through it and we'll see what happens. It's so sad. No RF tube. So sad. Okay, so the mixer tube is this guy. And I would get it off the top here. I've forgotten already which is which. One is oscillator, one is antenna. Okay, so I believe this is the antenna here. This is the one we want to inject the signal into. If I haven't got this right, it'll become apparent pretty quick. No harm will be done. Okay, we're going to feed the signal in. Small capacitor. This guy. I'm going to attached to the chassis somewhere. We'll just attach it right up here. It's quite clear the frame of the capacitor is bolted directly to the chassis. This is going to short out here. Okay, that's the input side of things. Now the output side of things, I have my pickup coil. I was saying we would want to be somewhere towards the output, and be somewhere right in this area here. Goodness knows what I'll pick up like that. And it's going to fall off. Here, stay like that. I'll leave it out. We'll move it around. We'll find out what's going on by experiment. Very good. Okay, let me get everything switched on and running, and we'll do it. Okay, first thing I want to do is turn the output up on the sweep generator and see what the SDR, where the antenna's just tucked right here, can pick up without the radio even operating. So let's just try that. So I'm just going to turn up the output here, and you can see something coming up on the SDR. It's quite obvious. So that is the rate in the IF range. That's the sweep going through. The angle on the top is probably due to the SDR's own behavior. Let me just turn off the delay, the decay here, and we'll see. Well, I don't know. That's odd, isn't it? This angle here. But the fact is, we don't really want to even see this right now because we don't even have the radio operating. So there's a couple things there. Funny angle. Let's try something here. Just put the delay, the decay on a little bit. You tune this radio and see if we aren't seeing an effect of the tuning. One way already. Oh, there's definitely an effect. Oh, now it's turned the other way. You're not exactly sure why what's happening on the screen is happening, but you can kind of tell now there's a peak in the middle. Maybe if I turn off the decay, you'll see it. See? So with the radio tuned here, somehow this frequency is peaked up. I don't know. Who knows? Something to simply be aware of. What I'm going to do is I'm going to reduce the input to the radio. So we cannot see any effect here. The idea being that any sort of leak over without the radio even operating won't be significant. So we'll turn this down until this disappears. That's pretty low. We are going onto the grid. Okay, so do another way. I'll use, this has some buttons here I can push. Down to the bottom there. Just turn this a wee bit more. Okay, so there's really no effect now. So we're leaking over to my pickup coil. Goodness knows if the pickup coil is in the right place. But for sure, if anything shows up on the SDR, it's because the radio is operating. Let's get it operating. We're still in the AM band here. There we go. Volume. Full supply voltage. Speaker still connected? No. Speaker wires come off. So that's the sound of the sweep. Now we see something quite different in that area, in the IF area down here. Instead of seeing the big full square, we're seeing the response curve of the IF. Perfect. So we're gonna zoom in on this area here. take off the decay. We should get a fairly nice curve out of that, which we do. If I were to pick the center of the curve, I would say it's right here, 451. So it's supposed to be 455. So to adjust this, I can either use the SDR the way it is now and trust that it's doing the right thing. I can use instead a scope. I think I need two things here to be sure. So let me stop for a bit. Let me get the scope going here. We should see the same curve. And then I'll need to introduce a marker amplifier to judge the peak of the curve. And I should do this just to verify that. Although I really don't have much doubt here that the SDR curve is accurate. Okay, stop for a bit, we'll do that. Okay, there we are. You can see the curve on the scope. Yeah, it goes down. Doesn't matter. Now, is it a perfectly smooth curve? It looks like a funny little bump or kink right in here. Now, can we see anything like that on the SDR? Let me turn off the decay. The SDR is producing a nice round result. What we don't know is we don't know the frequency here. I have to introduce another signal generator here. I think what I'm going to do is I'm going to let this run for 5 or 10 minutes. Everything warm up and settle down, including the oscilloscope needs to warm up a bit. And then we'll get back at it. We'll just add in this signal generator here. And we'll try to identify the exact frequency right here, which, if everything's right, is 455 kilohertz. We will see. Okay, I think everything's warmed up and ready to go here. Let's hook up the marker generator so it will place a mark on here. We can move this over a little bit. Hook up the second signal generator to the input of the oscilloscope. That's what I want to do. How am I going to do that? Okay, touching it. Doesn't seem to make any difference anywhere. Yes, it does. Causing a shift. Hooking up the second signal generator has caused a shift here, so I'm going to have to hook it up. Well, you got to wonder. Didn't seem that hooking up the oscilloscope caused a shift. But that's pretty tough to figure out, because every time you hook it up, it's hooked up to see it. Okay, let me turn off the sweep here. Right off. Better keep it on like that. And we'll just depress it so it can't show up. Turn up the radio. Now, what we want to try to figure out is the equipment I'm connecting, is it disturbing the radio so much the test is invalidated? So, tune in something here, anything. Okay, there's a funny little sound. Okay, so what I'm doing is I'm tuning in the radio to the funny little sound. Now, we don't want to watch, we want to listen. We don't want to watch, we just want to listen. This is taking off the the marker generator. Muffled it for sure. Take off so the scope's having no effect. The scope input is 10 megohms. I have it on the times 10 setting. This is more like 100 ohms. It's very, very low. I don't know, actually I don't know if that's true, but it's much lower. I'm not sure what it is. You can hear it muffle it. Now did it retune it? Well, we saw the IF shift on the scope when I did this. I can isolate this with a little more stuff here. Let me find something. We use a small capacitor. Here's a combo capacitor resistor. I'll put this on here. That's with my hand holding it. Didn't do much. Now what about this? Same effect. We need a bigger resistor. We need a bigger resistor. I'm looking for a resistor with a clip. Don't have one. Using this on the last radio, I had it soldered in. Maybe I'll have to do that here. Let's put it on here. 10,000 ohm resistor. Okay, now if I could just get that clipped on there, that'd be great. Almost. Okay, I think we're connected. Doesn't seem to be disturbing things. And I can increase the output of the other signal generator. Let's look back here. And turn the volume down. Turn the sweep up. There we are. Okay, watching the sweep now, I'm going to connect and disconnect the other signal generator. Barely made a difference. Still making a small difference, but it's very tiny. Just barely moved this. Good. Now I'm going to boost. Well, first we got to get the other signal generator down around 455. We'll see what happens when we get down there. Here we go. I'm watching the oscilloscope here very carefully. No evidence of it whatsoever. So jack it up a little stronger. 455. Okay, still nothing there. Give it all it's got. We're not seeing anything. So I'm hoping to see a little wiggle on here. I'm not seeing a thing. So is that because this really isn't connected here? No, I think it is connected because we saw this shifting back and forth. What's happened is I've just cut it back too much. Okay, let's do this. Okay, causing a small shift. I think I can see the wiggle. Let's see. So I'm changing the frequency of the marker to look for it, and I don't see it. I really got it on 455, right around here. No, it's not working for me. Things are not working out here. What's happening that it's not working out? Let me do that. What I've just done is I changed from times 1 to times 10 on the scope input. Now let's changing the size but not the position of it, so it's not causing a tuning problem. Does that make it easier to see the other signal? Well, you have to have a heck of an eye. Can you see that this is now shaky right in here, right in this area? In fact, you can see something kind of traveling up a little bit. I wish I had a little more juice out of this. I think I can. Get more juice. There we are. Okay, this might be a little hard for you to see. I'm going to move it back and forth. So when the other signal generators, and this is a frequency domain display, by the way. I didn't really explain that. So this is bottom of the IF, this is top of the IF passband, and this is a response curve within the IF. 455 should be right down here. Now when I move the other signal generator, you can't see it in here, it's not strong enough. But when we get down here, you can see the effect of it, at least I can. And you can probably see that something's going on. See if I can fly this camera right in here. This is how you get shocks, holding on to too many things. Okay, see the bottom of the curve is stable. Now it's a little shaky, and then it's stable again. That's me passing the marker through. It's very subtle. Can I just steady this a little bit? There we go. This is one of the worst. So I'm trying to maximize the wiggle. The wiggle is there. Hold the camera still. The camera's rotating on that. Okay, so there we are. I got the wiggle right at the bottom of the meter. I don't know what's going on with the camera. It's doing its own thing. Oh, I was standing on the wire. Yeah, standing on the wire, pulling on the camera. Okay, we're all done. And the frequency is 450. Same as what the SDR showed. Not 455. Well, interesting question now. Usually you're looking at a display like this while you make more adjustments in the IF. You're trying to get this to be a perfect curve right at 455. The SDR is also showing a curve. Can I work with that? That's the curve the SDR is showing. The red line is showing what I think is the peak of that. 451. Matching the other signal generator. Oh my gosh, I just about fell over there. Turn down that other signal generator. Well, I guess we can keep both up on the display. I guess there's no reason why we can't do that. I can actually remove the we're going to trust the SDR. Appears to be saying the same story as the scope. Okay, just getting rid of the other signal generator. That's a great thing about looking at the SDR. The frequency is marked across the bottom here. So we're going to want to put this over to 455. That's where the peak should be. And we're going to try to move the peak there. I'm going to allow the SDR to rewrite itself a bit there. And I'm going to increase the input here a little bit. Doesn't help much. It really shows up on the scope. So what I'm doing now is I'm increasing and decreasing the input signal. Again, I can't see what I'm doing. And I'm looking at what happens to this peak as I increase and decrease. You can see it's moving over. It moved over a little bit just from turning this up, turning it down. I guess when it comes to aligning a radio, you can make a decision whether you want it to be aligned for strong signals or aligned for weak signals. The normal thing is to align it for weak signals. I guess the idea is A strong signal doesn't require a really well-aligned radio to operate. But if you're going to go after those weak guys, then you want the alignment to be kind of focused on the weak stuff. So if there is some kind of drift like this, I don't know exactly why. It drifted a bit. I mean, it could even be my signal generator is not behaving exactly the same when you change the output level. Hard to say. The difference is minor. Okay. Now, what happened on our SDR here? It just went too low. Too low. Too low of a signal. Okay, let's move it over there. Gotta get at. We'll travel back a little further. Back a little further yet. So we got 2 IFs here to do. And grab a screwdriver. It's a little teeny puny one. Oh! Trip on the cord. Must be my day for falling down. Okay, we're going to try to move this thing over now. This is tricky business. Wow, these screws are hard to turn. Why'd that drop way off there? So I'm looking for evidence of the, like there's basically 4 humps, one on top of the other, making the main hump. And if they're all on top of the other, then it looks like one response curve. But you can see the individual ones if they're moving around, and you look for little distortions and bumps. You can also hear that it's fading out. Wow, it's a lot easier to look at the oscilloscope and do this. Okay, so I'm going to do that. I'm looking at the oscilloscope now. It's got a funny bump out here. When you do this with the more typical, just the single frequency, it seems much easier than doing it this visual way. Okay, next let's go down here. Oh, these are so hard to turn. I need a much bigger screwdriver. Okay. There we go. There, that's a thing of beauty there. Look at how much bigger it got. So the bigness off to the side, it's biggest when it's off. I don't want to touch that. Hold still, radio. Gotta put my hand on it. Okay, not happy about putting my hand on the chassis. Okay, that one there. This won't really change the overall performance of the radio. It's not far enough out to have done that. So you can see the peak is actually sitting way up here on this curve right now. I'm going to bring it down. It's coming in. It just went past. You can see it going up the other side quite clearly. So I'll go back. She's in. Okay, and this is centering. Oh, we've gone too far according to the SDR. Yeah, too far, Jim. We'll go back a bit. Too crazy about this in a second. IF. Something else that is the width of this is changing. So you can stop with this kind of like a sharp point, or you can stop with it like a rounded curve. And that causes a lot of tone differences in the what you hear coming out of the speaker. And generally, I guess with the communications, you're going to want it about as sharp as you can get it. So that's a pretty nice looking curve there. These always look a little different on this side from this side. that probably has to do with the something. How are we doing now? Pretty close on the 455. I look at the SDR, it's pretty darn close. Curve is nice. We're good. This is good enough. Okay, that's done. Now we want to check each shortwave band and verify that they operate, they're relatively well aligned, and we can't do any of that with a sweep generator. I don't have a sweep generator I care to employ for this higher frequency stuff. Okay, so I'm going to stop for a minute and get that all set up. Okay, let's start with this test. I happen to have my signal generator at 450 kilohertz. It's hooked up to the antenna. The output level is kind of medium for an antenna. And can you feed in the IF frequency at the antenna and hear it come out the speaker, which I think you may be hearing right now. We're hearing it right now. It won't matter where I tune the radio. Let's tune this guy and see when we get the strongest signal. Okay, based on my ears, 456. Okay, that's good. We're in the 455 range for sure. But that's not where we want to test this radio. Ungrounded chassis. What was that last sound? I don't know. That's okay. That's fine. So we're going to go. I just have to make sure I'm not holding on to it. This is now band number 2, which goes from 1.7 up to around 5. So we're not likely to ever listen on here. Ooh, listen to all that stuff. We'll dial in 2 megahertz. 2 megahertz. Okay, and we're going to dial in 2 megahertz on here. We'll see what happens. So we put 2 on here. I have to set this just below 2 megahertz because of its own error. And then we tune this in. You know, it's right on the 2. Okay, we'll go up to the other end. Well, that's interesting. That's a harmonic coming from my signal generator at 4, and I'm picking it up right at 4. So that's actually the end of the test right there. It's quieter because the harmonic is quieter. Alignment is excellent. Sensitivity is good on this band. Okay, next band. If we go up, say here, that's 12 megahertz there. The radio is very quiet because I've got it hooked up to the signal generator whose output impedance is low. So in a sense, there's a bit of a short circuit on the antenna. But I do have an antenna matching network down there. Those few components you see hanging out. I believe that's called the SMA standard, but I may have that wrong. And the idea is you're mimicking the kind of antenna. You're letting the radio see what it thinks is a regular antenna when in fact it's the signal generator. And the capacitors and resistor are there to kind of mimic the effects as you go across the band up in frequency and that. So in the end, as you're working on the radio is in a more normal environment. If you hook the signal generator straight up, then it might disturb the radio's alignment and whatnot just a little bit. Okay, so we're on 12, so we got to go up to 12. 12 megahertz. We're at 20, coming down. Same signal strength. Oh, maybe not the same signal strength. Let's just go back for a minute. I'm going to calibrate this. Signal strength is way off calibration. Okay, so that's lower now than it was. It's not quite as much output. What about here? Way down. So we'll turn up, calibrate, because we want to be able to compare these things as we go along. 1,000. Okay. Ooh, what was that? That funny chirp there would sound to me like the slider came open on the volume control very briefly. Okay. There we go. Is it 12? Ooh. Oh my gosh. Okay, so that's about 1 megahertz out. 1 megahertz is double 455, roughly. Yeah, it's 900 in fact, but megahertz is rough. Could be we just picked up the image. Let's go down to 12. Oh yeah, much stronger signal there. Much stronger. Knock it down. Knock it down. This now represents a weak signal on an antenna. So if you had a long wire antenna of the backyard and you're listening to very weak signals, this is the kind of thing that the radio would be working with. And listen, it's picking it up. 12 is actually here. Where's that on the dial? Well, right there. I mean, it's right there. You can't get this too much more accurate. Let's double check the image. So this is the real signal. We're tuned to the image 900 kilocycles higher. We should be quieter. I mean, ideally we shouldn't hear it, but we're going to. There it is. Barely hear it. So a weak signal at the image, it would be very hard to hear. But what about if there was a stronger signal there? Well, you can hear it as clear as a bell. It's one of the limitations this radio is bound to have on shortwave at the higher ends. Probably going to get worse even on the higher band. Probably can't tell the difference between the two of them. But I think that's the nature of the problem I was having in aligning this radio. But this seems okay. Very good. Let's go down to the other end and just check for accuracy. Notice I'm leaving this up on 0 here. What was that? Some noise signal. We'll try it around 6 megahertz. Okay, change bands here. Recalibrate. We can do a comparison. And 6. Okay, I'll put it right on 6 here. That's not a very strong signal either. It came through nice. That's about 6. Where is it? Okay, so it's a little off down here, but not bad. And the signal sensitivity is good. Now, let's add another 900 to this number. That would be 68 or so, 6.8 megahertz. Can we hear it? 6.8 megahertz. Yes, you can always hear it. So that's an unfortunate situation. To get around this problem of the image becoming very easy to pick up and potentially interference when you're using a radio like this, is to have a better front end with that extra RF tube and another set of coils and capacitors, another set of tuned circuits to go through. And what that'll do is that'll knock down the, see, I'm trying to show my hand, around the signal you want. You're going to knock down all the other stuff more than this one. Okay, let's go up to the top band. So far, this radio is actually working probably as good as it ever did. That would be my guess. Top band. We're on the top band. We're sitting at, let's go to 15, just for fun. Nice round number. We're dialed in at 15. Okay, we'll go in here. We'll calibrate. Can't get it all the way up on my signal generator. That'll be good enough right there. Close. So now we're still putting in the moderate antenna signal, and we want to do it at 15. 15.2. 14.2. So, and 14.2 is quieter. So it would look like in this case I've arranged the alignment so the local oscillator is below the target frequency. Why did I do that? After doing all this charting, I concluded that was the way to do it. I didn't make a lot of notes here. This is from quite a few months ago. Two question marks. So that's how this radio is aligned right now. So go back up to 15. Just to prove that, we're going to go above 15,900. So that would be just over 16. Do we hear it again? We do not. So this proves the local oscillator is running below the target frequency because the image is even lower yet. Is that correct? I think that's the final issue I had with this radio. As far as I know, there was no information anywhere to be found about how this should be arranged. So, sensitivity, it's pretty good. Let me lower this another factor of 10. So this is a pretty weak antenna signal now. Where'd it go? Okay, not that anybody's up. Well, actually, you can pick up shortwave at these higher frequencies these days. Let's put this up to 28. There's a ham band up here, which I've been using. I've been using like 2 and 3 watts to make contacts in Europe and across North America. It's amazing. 2 or 3 watts using whisper technologies to do it. If you're a ham guy, you know what I'm talking about. Okay, now I dialed this to 28, so we'll go up to 28 here. See if we've got any output left. Oh, there it is. Let me calibrate. Calibrate. Okay. Well, that's a very weak signal coming through really well. This is very sensitive at this frequency. Now again, we should find the image 900 below. 900 below would be 27.7 or so. I don't hear anything. Above. Okay, that's the tune frequency. Above would be 29.4. Wait a minute, wait a minute, how can this be? Is this actually louder here? Yeah, I've aligned this radio in both ways. At the lower end, I've forced the local oscillator below the target frequency, and at the higher end, I've forced it above. It depends upon the kind of alignment controls that are available for this band. Maybe I've hit the problem here, if there is a problem. So if we take a look, this is the band here. Make sure oscillator. Well, here all you're doing is adjusting the oscillator, and you're doing it at 30 megacycles. That's all. So there isn't like two oscillator adjustments. There's only one. So you can't be like pulling and stretching the linearity of the local oscillator, so you've got it above the target here and below the target there, and then it would be quite a mess in between in terms of the dial matching. Let's try that again. Maybe I just moved this up completely. So this isn't actually making a lot of sense that it would be like this. So we're tuned to 28. We're listening to 29 450 because the dial's not quite accurate up here. We're getting this kind of signal strength, listening just to the volume. And now I'll go down to the doesn't sound much different at all. This again is a difficulty with these radios. At the highest end, with only a single conversion stage, they're going to have a hard time, I guess, sorting out the images from the real McCoy. Just using signal strength. They're both going to be about the same strength. That means this guy's a bad actor for tuning up in this area, tuning on these higher frequencies. Because when you tune it to 28, you might actually be hearing a signal at 29 megahertz or so, a little below. And you can't tell when you're operating a radio. You can't tell. Not without investigating. So we don't know what's going on here, for sure. We could, if we look at the local oscillator. I think that's a helpful thing. We can do that in a bit. Let's go down to the bottom again. I'm still just doing assessment here. 6. No, 16. 16. Don't make that mistake. 16 megahertz. What do you got going? Down right into 16. 16. 15, 16. Okay, so there's 16.2. For some reason there's a 200 kilohertz high here and high up there. Don't know why. Now we want to find out where the local oscillator is by looking for the image. Is the image above? I'm going to turn the level up here. Is the image above? Doesn't seem to be. So I'm calling it the image, but I don't know which one's the real McCoy here. Again, the volume level's so very similar. So this is telling me down here the local oscillator is below, and up here the local oscillator is above. It doesn't make any sense. Got to be coffee time. We need to take a closer look at this somehow. Get a better grip on what's happening. Yeah, coffee will help with that. Okay, here we go. Now the SDR is set way low. We want the SDR up in the range of the receiver. So 16, maybe 20. We'll see if we can set 20. The SDR can only see a little bit of the band at the time. It can't see the whole thing. I think it's about a megahertz wide. So let's set it right at 16 and we'll investigate what's going on here. 16 megahertz. 16, I'll set this to exactly 16. Oh, we gotta move this in the middle. 16. The red line is showing 16 megahertz. Now, I want to move the pickup coil here around until we're picking up the local oscillator, probably right near the front part of the radio, maybe right in here. Does anybody see anything showing up? Maybe right near this first tube. I didn't see anything there. So we're tuned to 16. The local oscillator is either 455 above or below. I'm thinking it's below right now. That would be 15,500. 15, well, it's nowhere near on the screen. Oh, this is zoomed in. Okay, let's zoom it out. That's the problem. Zoom out there. Oh, wow. There it is. There it be. Okay. So we're going to put 16 back in the middle of the screen here. 16. And I'm going to put the red line right on the local oscillator frequency. 15830. That's kind of a weird number. So we're tuned right on 16. If I change the tuning, the local oscillator will wander around. And bring it back. Okay, let's analyze this. Dial says 16. SDR says local oscillator at 15830. Below 16, but it should be like 455 below. So probably the oscillator adjustment on this band isn't correct. I think I was working on this band and I couldn't sort it out, and I just kind of threw my hands up. So at this point in the band, local oscillator definitely below. Okay, so we'll go up to here. This is 20. No, this is 28. Okay, we'll take this up to 28, or in that area. 28. Whoa, that's all that stuff. Um, 28 is actually not on the screen here. Okay, that's a little unexpected. What is all that? Tune this a little bit. This could be trouble with the SDR. I could be overloading it. It's not too likely. I'm just using a pickup coil. Oh, pickup coil moved a bit. What is going on here? Maybe what's happening is I still have, yeah, you know what? I've still got the other signal generator putting a signal in right around here. The other signal generator is running at 15.3. Okay, so that's pretty accurate. So if we look on the SDR, well, 15.3 is nowhere near here, but wait a minute. 15.3 doubled is 30.6. 30, well, that's over here. Okay, let me vary the signal generator there, and we'll just see if what's on the SDR starts wandering around. It's really quite mysterious what I'm seeing here. No. No. Not at all. Okay, so if we take this up to the 28 range, 20, 22, 24, 26. Oh, here it comes. Wait a minute. I'm going up. Why is it coming down? Oh, I know why. I think I know why. So my SDR has a limit around 25 megahertz. At that point, it stops processing properly, and you have to change to a different style of processing in the SDR. That's probably what's happening here. So, okay. It's hard to remember all this stuff. So I'm going to switch now to a different kind of processing. I have to switch the antenna input on my SDR here over to here. This is a little bit of a, this is, you know, it's a cheap SDR. Okay. Now I need to switch processing. If you watch, you can't see what I'm doing. Well, maybe you can when I'm going to stop the SDR. I'm going to call up this dialog box. Good, you can see it. I'm going to switch this from direct sampling Q to quadrature sampling. I'm going to say go. That should give us a different view of things. Yeah, that's much better. Okay, perhaps I drove myself crazy this way last time. Having the SDR set incorrectly, but not so bad. It didn't show signals. It showed signals, confusing signals. Now, is this less confusing? So we're tuned to 28. 28 is off the screen down here. This has to be the local oscillator, this big whopping signal. This might be my signal generator, 28.17. That's exactly what that is. This is the signal generator. And in the signal tuning, there's nothing there to see on the SDR, an actual tuning point. Well, let's figure this out. If the local oscillator is at 29,100, let's say, then the radio is tuned to a frequency 455. Away from that, going down, it would be 28.7. Hey, what happened there? My signal generator just suddenly took a drift. What did I say? 28 something. 28 something. Well, where is it tuned? Where? Let's do this. Turn this radio up. We'll run the signal generator back and forth till we hear it. Okay. Oh, jumper. There it is. Okay, so that's, sorry about the volume there, 28.6. I'll just leave it off so we don't have to listen to it. 28.6. And we're tuned to 28. That's suspicious. We're tuned to 28. So with the radio tuned to 28, the local oscillator should be aimed for 28.6. And that is what I worked out, isn't it? Well, here's 28.6. What's that doing there? Oh, that's the local oscillator slightly off. If I move it a bit, it'll hit the tune point. Hey, let me find it on the SDR here, just for interest's sake. I can still hear it slightly, so it's here. So this is what the radio is actually tuned to. 28.65. Now, my calculator here, I don't want to make a mistake. 28.650. We want to add to that 455. So we add 455. 2910. Now, is that where the local oscillator is? No. 29,100. 2910 is down here. What just went wrong here? This should be 455 kilohertz between these two signals. Okay, let's try this. The local oscillator is 29.1. Okay, we'll try that. That's my calculator's fault. 29,100 minus 455 equals 28,645. 28. Yeah, there we are. 28,645. Close. 28,645. Sure. 645 is right there. Okay. Just out by a touch. That's no problem. That's less than the width of the dahlier, I bet. So this shows a local oscillator above the target frequency. The other end is below. So, because of the kind of capacitor in this radio, where the size of these is about the same, that suggests that there's a series capacitor in the oscillator circuit that would need adjustment. And we would find it If we look at the band A, oh no, it's way down here. Oh, okay, so supposedly you're doing the shortwave bands and then doing the broadcast band. I've been kind of going at it a little bit opposite. Sure enough, there's two oscillator adjustments here, trimmer and padder. Likewise here, oscillator, trimmer, and padder. But on the higher frequencies, it's just oscillator and oscillator. There's no padder. Oscillator, trimmer, but no padder. The trimmer's in parallel with the tuning capacitor and the padder's in series with it. Apparently not required on these higher bands to put a padder in. You have to think about that for a while, why that would be the case. I could assume when I did the alignment the first time through, I followed these instructions closely. And I would have done the padder here. I don't know, could that even be the cause? I mean, this is way out. This is way out up here. This is way out. Am I on the ball? That's just... So absolutely for sure, the local oscillator is above in this case. That means we would tend to hear any frequency that should exist 455 above. So we take this complicated math here, 29.1, we add 450 to it, we get 29,550. 29,550 is about here, 29,550, about here. It's about where this is. That's curious. What's that doing there? Is that exactly on? 29,540. Is that just a coincidental signal here? Just happens to be there? Like some interference signal? Okay, so if I move this signal generator up to the other side by 450, which would be right around here, we should hear it again. Okay, so we're going to do that. Okay. Here we go. How loud is that? That's loud. You can hardly hear a difference. Louder at the bottom. So louder at the bottom when the radio's tuned to 28. It's actually picking up 28.6. Or is that the right? That's the lower one. Conceivably, if you're tuning this radio with a local oscillator above, then when you tune to 28, you're actually tuning 26, but you can get an extra bump from 29 something or other. But when we go down, well, if we could go halfway, and what's happening halfway? Well, how would I even tell what's happening halfway? Take it down to 20. Change the SDR to 20. Is just nothing there at all. Let's tune the radio till we see the local oscillator. Where'd you go? But I did something stupid here. Did I? This is on 20. tuning something in right there. Where's the local oscillator? Should be just whipping through there. What am I doing? I've got the SDR. Oh, I've gone below 25. Right. Okay, so SDR cannot process signals below 25 the way it's set up. So I'm going to move. This is probably why I got this all messed up the last time around. Failing to make this change on the SDR while using it. And that's probably that. I mean, that would cause massive confusion. Okay, so we're now ready to operate, almost ready to operate below. To change this back to direct sampling Q branch. Okay, and local oscillator, where are you? Here he comes, here he comes. Okay, so if we tune this to 20, we'd expect the local oscillator, if it's above, to be above 20. Let's pull this over here. 20 is located here. You think the radio's tuned there. The local oscillator is very close to it. It's 100 kilohertz away. It's kind of like this. I don't know if I can demonstrate this with my fingers. So let's do this. This is the tuning. And in the background, the tuning meaning the dial setting. And in the radio, the local oscillator is running, let's say 450 above. So as you tune to 2, they should do this. They should just be tracking along together. And no matter where the dial is set, the local oscillator is 455 above. What appears to be happening is at the high end it's like this. But by the time I get to the low end, it's like this. Yeah, if this is what's happening, this would cause massive alignment confusion. No matter how many times you try to align this thing, you're just going to get all confused. If you try it in the middle, then you're gonna have it out here, and you're gonna get this kind of thing. Something like that's going to happen. You can't win. You can't win with this radio. Why would it be like this? I mean, they designed these radios to not be like this. The last thing they do is they have the scale match up finally. They force the scale to match. I'm not sure what that just was now. So the question, what am I going to do about this? I don't know. I think that's a topic maybe for tomorrow. If there's anything I can do about it. One possibility is, and I'm just shooting in the dark here, that this pattern setting is not correct. But I think this pattern is only in the circuit when you have this band operating. The one we're looking at is this band up here. They say do everything at 30 megahertz. Now that's an interesting thing. If you do everything at one frequency, you'll get it all lined up there. You'll never know what's going on the other frequencies unless you investigate. Or later during the use of the radio, you begin to realize this is kind of weird. How come I'm way out of band and I'm picking up shortwave here and there? But it'll be fine at 30. 30's way up here. It's not in the middle. So another way to look at this is where do you want it to work right? So a radio like this, you're most likely only to listen to shortwave, maybe on the 19 meter band down here at 15 megahertz. Although, the way the sun's been operating, the sun, I can't think of the term for it now, just now. The solar flux index, SFI, solar flux index, has been very high, up around 120, 130 for days. And I think it's going to stay like that. That makes these upper bands available during the day. And they are, as I mentioned, fooling around on my ham radio up on those bands. Well, I think to some degree it's a write-off. Perhaps you just, I don't know, what would, well, let's take a look at the schematic and just see if there's anything there that somehow works. Somehow works. So we'll pick the band we're on. Did they number them? Did they number the bands? P-O-N-M. M-N-O-P. Q-R-S. There's a 2 there. They did not number the bands. 15, 20, 23, 25. That is must be all numbers referring to something else. 19, 16, 18. How can we possibly tell which band was which here? Come on. Isn't this annoying? This kind of stuff usually would be on a broadcast band. Is there a hint? Did they hide the hint here? Oh, look at, they're talking about the image ratio. Now that's interesting. Now look at this. 2.7 to 1 at 30. So I think what they're talking about is the ratio of these voltages. So at 30 megahertz you would find if the signal was 2.7, the image would be 1. A little less than half. That's not much different. That's not much different at all. Down here it's 6 to 1. Still, it's not a lot of difference. Here it's getting better. And on the AM band, of course, 35 to 1. So you never have an image problem down here for a couple of reasons also. But up here, it's really not, I don't think it's suggesting it's a very good radio. I'd have to look at another high quality radio. The solution for this is double conversion, and this radio does not have it. So I think this is kind of like a pretend communications radio. So if this is the AM band, we could assume this is the top band here. C2 is an adjustable. If we look at the instructions for alignment, which I've got on paper here, let me see, which one are you doing? We're going to do, what are we adjusting? Well, this just gives the name, oscillator trimmer. Adjust slug pattern or trimmer number. Here we are, 12. Okay, so it's number 12 that would adjust the oscillator, and the mixer is 8 with a special symbol. So 12 to, so here's an 8, and the 12 would be down here. There's the, where's the 12? 12 right here, C12. And this is C2. Wait a minute. Slug pattern or trimmer number. Number is 12 for 30 megahertz. We're adjusting trimmer number 12. That's an oscillator. Or number 8. Okay, I got it. And 8, 8, 8. Hey, wait a minute. There's no 8. 4, 3, 2. Where's 8? 12, 13, 14, 15. More adjustable capacitors, please. Ooh. So here's the ones that are in series. See, this guy's in parallel with the coil. This one's in series with the coil. That's not at all what we're looking at. We're looking at, I'm really getting confused about this once again. So take a look again. 8 is the mixer trimmer. 8. C8. Adjustable. adjustable. Where are you? C8. C7A, C7B. It's interesting, but it's not C8. It has to be an adjustable one. Wait, the heck, over here? Can't be over here. C7C. C9. There's a C8. It's not adjustable. There's an error here, maybe. No, it can't be an error. I'm looking at the alignment instructions for the different radio. Alignment instructions. No, this is this radio. It says at the bottom, always give model and serial number. Well, you tell me what the model and serial number is. This isn't working out. This has to be the right radio. There's no hint. Top view of chassis, and the pictures are terrible. Okay, top view of chassis. Wow. Terrible picture. I'm sure this is correct. This is correct. I'm sure this is the correct sheet. And so it's saying, well, this might add to the difficulties here. Adjustment number 8. Mixer trimmer. The mixer trimmer has to be one of these. 5432. Well, what do you do in a case like this? There's C8. Not adjustable. Did they forget to put the adjustment thing on it? 220. Don't think so. Not with 220 written there. Wouldn't normally put the value beside these. They're all basically close to 0 and up to 10, 15 picofarads. I think what's happened is they've accidentally said 8 instead of 2. Okay, so is there a place where it says adjust C2? I look down the list. There's never a time where they say adjust C2. And 8 is not an adjustable thing. 8 is not adjustable, so it shouldn't be in this list at all, but it does. It appears here. And it's not a typo. There's an error on this sheet. No wonder. No wonder. Let me show you. Okay, did I come across this before? There's the 8. Mixer trimmer. And in this list, nowhere does it say adjust to. 5, 6, 9. Isn't it 4, 5, 6, 7, something like that? What is going on? Okay, so this is saying when it comes time to do the, watch out, some of these are patterns. There's a 10, 11. 10, 11, both of them trimmers. Mixer trimmers, they're calling them. So 11, 10, 9, 8. 11, 10, 9, 8. Okay, let's go back. Just look up on the top there. 11, 10, 9, 8. I haven't got the right information here. 11, 10, 9, 8. 15, 14, 13, 12. Where's 11, 10, 9, and 8? Something is really amiss here. Okay, I've had enough of this for today. I'll look into this question of how I got the right sheet here. This picture matches the top of the radio. This picture matches the underside of the radio. Not 100%. Because in this show, I won't go into what it is. Nowhere on this page does it say which radio this is for. That might be the root of all my problems in trying to align this radio. Instructions are wrong. Okay, that's a good place to end for today. Thanks a lot for watching. Tomorrow I'm going to settle this thing down one way or another. And that'll be it. That'll be it for this guy. Whoop. Yeah. So thanks a lot for watching, and we'll sort this out tomorrow. Son of a gun.